In this video, we will cover the basics of Module 4 on OLI, Open Learning Initiative, examining distributions. This is not a substitute for the OLI reading. You will need to read OLI and complete the activities in detail. In this module, we'll make sense of the data by studying either quantitative variable or categorical variable. We do this by examining the distributions of the variable, and by distribution, we mean what value the variable takes and how often it takes these values. We will take a look at two examples. For the first example, consider the research question, do you have a pet? The responses will be either yes or no. Suppose we survey 11 people and we obtain the responses yes, 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 no, 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 yes. Now the answer varies, yes or no, so that's why it's called a variable. We might name this variable pet ownership. It is a categorical variable because we can group the responses into two distinct groups, either yes or no, categorical variable. In examining this variable, we see that it takes on two values, namely yes and no. It takes the value yes 5 counts, yes, 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 and no 6 counts, no, 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 no. Note that the variable is again categorical. It is very important to identify whether the variable is categorical or quantitative. Let's take a look at another example. Suppose our research question is now, how many pets do you have? And we add 12 different people. The responses will be 0, 2, 1, 0, 1, 5, 2, 5, 2, 5, 2, 1. We might label this variable, they vary, number of pets. Now we see that it is a quantitative variable because the values are numerical, and if we were to add the two numbers of pets, it makes sense. So for example, we might say that on average, there will be 3 pets per person, and that makes sense. And that is why the variable is quantitative. This quantitative variable takes on the numerical values 0, 1, 2, 3, 5. These are the responses that we obtain. It takes 0, 2 counts, 0, 0. It takes on 1, 3 counts, 2, 4 counts, 3, 1 count. There's no 4, and then 5, 2 counts. And so basically we count the values there. For categorical variable, which is the first example, we summarize the data by computing the percentages. The percentage will be computed using the count of a value over the total counts of all values. So for example, for the value yes, we counted that there were 5, and so the percentage will be the count of the value 5 over the total counts of all values. So there were 11. We had 11 responses, and then we multiplied 100. 5 over 11 times 100 is 45.5%. And we do the same thing for the value no. 6 over 11 times 100% is 54.5%. Note that the total percentage need to add up to 100. Now usually this is summarized in a table called numerical summary. The first column will be the values, the second column will be the raw count, and then the third column will be the percentages, the corresponding percentages. And again, the total need to add up 100%. We accompany the numerical summary with graphical displays using either pie chart or bar graph. These graphical displays for a categorical variable are known as pictogram. Now for quantitative variable, we will use histogram, stem plot, or box plot for graphical displays. In a histogram, there should be no gap unless the count is 0. So for example, earlier we had the counts of the number of pairs, which is the quantitative variable. This is what a typical histogram looks like. We see that there are 2 counts of 0, 3 counts of 1, 4 counts of the value 2, 1 count of the value 3, 0 count of the value 4, but we still need to include 4 because this is the number line. 2 counts for the value 5. Now, for large data sets, we will need to combine consecutive values into the same bin, such as in this case 0 to 1, 2 to 3, 4 to 5. If we were to combine values 0 and 1 and make it the same bin, then from 0 to 1, we now have 5 counts. And then from 2 to 3, we would have 4 plus 1 is 5 counts. And from 4 to 5, we would have 2 counts. Because again, we obtained 12 responses when we ask the question, how many pairs do you have? We then describe the distribution of a quantitative variable, in this case using the histogram, using the shape, center, spreads, and any outliers. The shape, center, spreads are called the overall pattern, and any outliers are the deviation from the pattern. When we describe the shape, we use the term symmetry, asymmetry, skewness, and peakness. The peakness is what we call the modality, the number of peaks. The center will be the midpoint. It is the number that divides the distribution into 2 equal halves. Spread is the variability, the minimum, the maximum, and the range. And outliers are any observation that fall outside of the obvious overall pattern. In addition to using the histogram for a quantitative variable, we might use a stem plot or a box plot. We accompany these graphical displays for a quantitative variable using numerical measures. The measure of the center will be the mode, the mean, the median. The mean is very sensitive to outliers. The measure of the spread will be the range, the interquartile range, IQR, the standard deviation. We will use 1.5 IQR rule to determine any outliers, where the IQR is the interquartile range. It is the number that is computed using the difference between quartile 3 and quartile 1, Q3 minus Q1. The box plot is the graph of 5-number summary. This consists of the minimum, quartile 1, median, quartile 3, not 2, the maximum. The minimum is the smallest value in the data set. The maximum is the largest value in the data sets. The median is the number that separates the data set into 2 equal halves. Q1 is quartile 1. It is the median of the first half, the middle of the first half. And Q3 is the quartile 3, the median of the second half. The box plot is drawn accordingly based on the number line. Now, we just went over the basics of the OLI reading of Module 4. You will need to spend time reading OLI to understand more about these topics that we just mentioned.